All right, guys, I'm going to get started. Can I get a thumbs up at home that you hear me and see the board okay? Awesome. All right, guys, here we go. I'm going to start the next section, and just to kind of, again, give you a nice, easy week, I'm going to teach you today. I won't give you homework, and then I'll give you the homework in class tomorrow, and then we get to go on spring break, okay? And if I could just put a little disclaimer out there, like, guys, I get it. Photo math is definitely being used a lot. All right. Sometimes it takes kids 2 minutes to take a 15-question quiz. I'm not an idiot. I can't control it. So I just try not to think about it. But I understand that a lot of you are doing math this year strictly by photo math. Listen, I've told you before, it's a disservice. You're going to go into next year, not be able to use photo math and have no idea what you're doing. There's going to be a college math placement test one day. Photo math ain't going to be there, and you ain't going to know what you're doing, and then you're going to pay for a college class that you don't get credit for because you couldn't pass the math placement test. I've tried warning you, but that's all I can do. I'm going to warn you today that if you're a photo math person, photo math doesn't do these problems the way our book wants you to do them. So they're not going to get you the simplified answer that we are looking for. So if you want this to be an easy homework assignment, I highly recommend you watch what I'm doing, because photo math don't do it the same way, and they don't technically leave you with a completely simplified answer. Just going to throw that out there. All right, here we go. So on the first day, we saw how to add, subtract, and multiply polynomials. Guys, it's awesome. We've been doing it all year without calling it, operations on polynomials. We've been combining like terms. We've been distributing. We knew how to do that. Division is always a little bit more complicated because technically it's dealing with fractions, right? So the division gets its own section. So this is the easy division, if you will. The hard division, I won't be able to start until after we come back from spring break. So this is as easy as the division ever is going to be. All right, so if you're going to divide polynomials, that kind of falls into a couple different categories. The first kind is when you take a monomial, a one-term polynomial, and divide it by another monomial, a one-term polynomial. So this is a monomial divided by a monomial. So guys, you'll notice there's no adding or subtracting, right? Because monomials don't have adding and subtracting. So if there's no adding and subtracting, you guys have already done this one in your exponent rules. If it's a division problem and there's no adding and subtracting, then you divide your numbers. And what do we do with exponents in a division problem? We subtract them. Big minus small, put it back where the bigger one was. So guys, we've already done this. Let's divide our numbers, which are 15 and 3. So 15 divided by 3 is 5. So that goes back on the top because that's where whole numbers go. Now let's divide our x's. X to the third divided by x. 3 is the bigger exponent. So 3 take away 1 is 2. Put it back on top where the bigger exponent was. So now we have x squared on top. Now let's divide our y's. Y to the 7th divided by y to the 4th. 7 is bigger, so we'll do 7, subtract 4 is 3, put it back on the top where the bigger exponent was. And now let's divide our z's. Z to the 12 divided by z to the 6th. 12 is bigger, so 12 subtract 6 is 6, put it back on the top where the bigger exponent was. So in this problem, everything went back to the numerator, the top, so you don't even need your fraction bar because you're allowed to leave your denominator empty. And that is the new monomial, one-term polynomial you get when you divide these two. So you've already done that kind. So we know how to divide a monomial by a monomial. But what happens when they start throwing that adding and subtracting in? Guys, as the higher level math you get in, you'll notice like, hey, adding and subtracting used to be the easy operations, right? It's the first thing you learn in kindergarten. Now, in upper level math, adding and subtracting ruin things. They literally make it impossible for us to do certain things, all right? So part 2 is going to be a little bit harder, but we've seen this before. We've approached this. If you're going to take a polynomial, right, of more than one term and divide it by a monomial, one term. So if you're going to take lots of terms and divide it by just one term, it actually stays pretty simple, all right? And it's based off of this. And I've showed you guys this, I think, 3 times this year already. Guys, if I asked you to do this, 10 plus 15 divided by 5. Technically, this is 2 terms divided by one term, right? So we could technically say this is a polynomial of 2 terms divided by a 1-term polynomial. Well, guys, lucky for us, we're allowed to add these together and get 25. And then it's 25 divided by 5. The answer to this problem is definitely 5. You cannot argue that the answer to this problem is not 5. But another thing that you're allowed to do when you have more than one term divided by one term, as long as there's no adding and subtracting on the bottom, you're allowed to do this. And we've done it before. You're allowed to split this into 2 separate fractions. You're allowed to take everything on the top and divide it by its own 5. So I can split this and say, hey, 10 divided by his own 5 plus 15 divided by his own 5. If you're only dividing by one thing, the only one term does this work for. So now 10 divided by 5 is 2, plus 15 divided by 5 is 3, 2 plus 3, you still get the exact same answer. Oops, I erased it. The exact same answer of 5. So that means because the answer didn't change, it's going to be okay to do this. So guys, this is what we're going to approach a more than one term polynomial divided by a one-term polynomial. We're going to split it. We're going to create a lot of separate division problems. But you're only allowed to do this when you're dividing by one term. If you were dividing by more than one term, like if this was the opposite, if it was this, then you can't split. Can't split when it's more than one term on bottom. All right, so let's look at it with polynomials now and watch how easy it is. Okay, so therefore, when a polynomial is divided by a monomial, one term, no adding and subtracting on bottom, you split them. Split it into a bunch of separate fractions. That's how we're going to approach this. And photomath doesn't approach it this way. And because they don't approach it this way, they don't get a 100% simplified answer like the way our book wants it. All right, so guys, see how you have a polynomial of 1, 2, 3 terms divided by a one-term polynomial. No adding and subtracting on bottom. Well, guys, we're allowed to split this. Take every term on top and divide it by its own 3xy. So take 6x to the 4th, y to the 3rd, divide it by his own 3xy. Take this 12x to the 3rd, y squared, and divide it by its own 3xy. And then take your negative 18x squared y and divide it by its own 3xy. And what you've done is you've created 3 separate division problems that we can now handle one at a time. All right, guys, let's go to this one first. 6 divided by 3 is 2. 2 goes on top, right? That's a whole number. We subtract our exponents. 4, take away 1 is 3, put it back on the top. Y to the 3rd divided by y, 3, take away 1 is 2, put it back on the top. So now we have 2x to the 3rd, y squared. Then we're going to get plus 12 divided by 3 is 4, so put it on the top. X to the 3rd divided by x, 3 take away 1 is 2, put it back on the top where the bigger one was. Y squared divided by y, 2, take away 1 is 1, put it back on the top where the bigger one was. So now we have 2x to the 3rd y squared plus 4x squared y. And then minus 18 divided by 3 is 6. X squared divided by x, 2 take away 1 is 1. Put it back on the top where the bigger exponent was. Guys, y divided by y is 1. They divide out of the problem, no more y's. And this is your simplified answer. Again, you would check for like terms, but I haven't come across a problem that ended with like terms yet. All right, and I'm telling you, truthfully, I think the way our book does it is easier than the way photomath does it. Photomath has you factoring out GCFs and it gets wild. And then in the end, it doesn't even look completely simplified. All right, look at this one. Same thing. It's a polynomial of 1, 2, 3 terms divided by a one-term polynomial. As long as you are dividing by one term only, it can always be made into a split problem. So guys, split it. Give everything on top its own denominator of 2x squared y squared. I'm sure you guys can do this without rewriting it, but I'm going to rewrite it. Now you'll see, they're not all going to leave you with this nice, beautiful, everything went to the top polynomial, all right? Sometimes your answer won't even end up being a polynomial because you might be dividing by a variable, and that's fine. All right, here we go. So 18 divided by 2 is 9. Put it on top. Whole numbers always go to the top. X squared divided by x squared, guys, anything divided by itself is 1. They divide out of the problem. No more x's in that piece. Y divided by y squared, guys, now the bigger exponent is on bottom. So 2 take away 1 is 1, but it goes to the bottom. And that's fine. Not your fault. All right, and then plus 10 divided by 2 is 5, so put that on top. X to the third divided by x squared, 3 take away 2 is 1. Put it back on the top where the bigger exponent was. Y to the fourth divided by y squared, 4 is bigger. 4 take away 2 is 2. Put it back on the top where the bigger exponent was. And then z divided by no z's just has to stay z. I haven't checked in. Are we okay? Is everybody okay? Nice and easy? Everybody's good? At home, can I get a thumbs up? Are we all right? Okay. All right, and then last, minus 7 divided by 2. 7 doesn't divide by 2. And every year I get a student that puts 3.5 on the top of a fraction. No. You don't want decimals. So if it doesn't divide, we look to reduce. 7 over 2 doesn't reduce. So it literally just says 7 over 2. All right, and then x to the fifth divided by x squared, 5 is bigger. So 5 take away 2 is 3, put it back on the top. 6 is bigger, so 6 minus 2 is 4, put it back on the top. And you're done. So guys, this is what I'm talking about. Your answers, they are definitely not pretty looking expressions by any means, but this is what you get when you divide this polynomial by that monomial, all right? And on your homework, which isn't tonight, I'm giving it to you guys tomorrow. Tomorrow, your homework is gonna be a Google form where I literally listed all the answers at the top of the form, and then all you have to do is match them to the correct problem, okay? All right. Look at this one. This is when they just start trying to throw you off and write it in a different formation. So guys, look at this one. They want you to take this polynomial right here, this polynomial, and they want you to times it by this polynomial that is being raised to the power of -1. Well, that's weird. We don't want negative exponents, right? So only this power of -1 is on this one. So guys, if this polynomial is being raised to a power of -1, where do you have to move it to make it to be raised to a positive power of 1? If it's on top, we move it to the bottom. So guys, really, instead of timesing these together, he's going to the bottom. So you're actually going to take this polynomial and divide it by this one, which is 4CDF. Now, technically, don't write this down. Technically, it's being raised to a positive power of 1 now that we've moved it to the bottom. But guys, we don't have to write positive powers of 1. So really, it's just down there as 4CDF now. So now all you have to do is split it. This polynomial is being divided by this one-term monomial. So we just split it. Give everything on top its own denominator. Okay? All right, so now if we individually divide all of these, right, we just split everything. Look, let's go to the first one. 20 divided by 4 is 5. Put it back on the top. Is this still on camera? Yeah. All right, c to the fourth divided by c. 4 is bigger, so 4 take away 1 is 3. Put it back on the top. All right, d squared divided by d. 2 is bigger. 2 take away 1 is 1. Put it back on the top. Oh, that's d. And then last, f divided by f is 1. They divide out. No more f's there. Minus 16 divided by 4 is 4. Put it back on the top. C divided by C is 1. They divide out. No more C's. D divided by D is 1. They divide out. No more D's. F squared divided by F, 2 is bigger than 1. So 2 take away 1 is 1. Put it back on the top. Minus 4F. And then last plus 4 divided by 4 is 1. They divide out. C divided by C is 1. They divide out. D divided by D is 1. They divide out. F divided by F is 1. They divide out. Guys, you literally took 4CD to the F and divided it by himself, 4CD to the F. Everything went to a 1. 1 times 1 times 1 times 1, what's left? 1. So plus 1. And you can't forget that. You can't like leave it blank and say, oh, look, there's nothing there anymore. There is something there. When something is divided by itself, it turns into a 1. The reason I don't have to write 1s here is because if I wrote a 1, 4f times 1 is still 4f. It's not going to change what was already still left. All right? Perfect. One more. How do you guys feel? Is everybody good? At home, 1 thumbs up. We're good? Excellent. Okay, like I said, this is pretty easy. This is a nice division. When we come back from spring break, we'll see the harder division. All right, last one. And again, just trying to show you the different ways your homework is going to show division. The last problem. Guys, now they kind of went back to like elementary school division and they used the division symbol. But we know better. If I'm going to take this polynomial and divide it by that polynomial, then show it as a fraction. And now you are literally taking a polynomial of more than one term and dividing it by a one-term polynomial. So we can split this. All right, I'm going to let you guys do this one. I'll do it up here. You do it there. Let's see if we get the same answer. And don't force anything to go to the top. If it has to go to the bottom, so be it. It's got to go to the bottom. Okay. Double check yours with mine, right? I just showed the division as a fraction, and I split everything, dividing it by its own 3x squared, y squared. I ended up getting 3xy minus, this is 6, but then the x's and the y's divide out to 1. They're not there anymore. And then plus 7. The x's have to go to the bottom because that's where the bigger exponent was. And then 3 is bigger, so the y's go back to the top. How many got that one right? Everybody get that one right? Awesome. All right, how you guys at home? Everybody get that one right? Good? Okay. So guys, that's how we're going to divide polynomials when it's a big polynomial divided by a small polynomial. This only works when you are dividing by a monomial. There can't be any adding and subtracting in the denominator if you're going to split, okay? All right, so like I said, I'll hold off on your homework again, trying to make this a nice, easy week for you guys. And I'll give you that homework assignment tomorrow in class, all right? And like I said, it's not going to be Delta Math. Delta Math didn't have great problems on this division, so I made a Google form where you're just going to have all the answers to all of the homework questions at the top. and then the questions will be on the bottom, and you're gonna match each question to the correct answer, okay? All right, can I get a thumbs up that we're good at home? Awesome. All right, let me check your attendance, and then you guys will be good to go, all right?